I guess we were going to start because the light's right here. Just a little bit before I get started, and you can like laugh at my cute American accent. Je m'appelle James Williams. Je suis un développeur et il y a 11 ans, j'ai étudié à Lille comme un étudiant Erasmus. Donc, je parle français un peu, mais je lis et je comprends mieux que je parle. All right, let's get started. My name is James Williams. I will be speaking to you about WebGL and Three.js. So a little bit about me. I am the co-creator of a project called Griffin, which is Swing for the Java desktop using Groovy and a bunch of other toolkits, SWT, JavaFX, and stuff like that. But lately, I've been doing a lot of work with HTML5. Recently, I published a book, Learning HTML5 Game Programming for Pearson. You can check that on Amazon. Right now, I'm writing a new book on Three.js, just kind of self-published because a year had gone past since I wrote the original book, and I just wanted to write something. I must apologize that I won't be at the conference for much longer after the completion of my talk, so you are welcome to contact me via Twitter, my blog, or in GitHub, or on Google+, and send me any questions or anything like that you have. Doesn't matter if it's French or English, I can respond to both, and I don't use Google Translate. So yeah. That's my book. Go out and buy it. Three.js book is available at this link. The cool thing versus a regular book is that the price is lower and you can kind of pay whatever you want. I have like a minimum price, but you can pay anything over that. It's about 50 pages so far, and that's the end of the sales pitches for this talk. All right, so we're going to talk about WebGL and Three.js, talk about creating scenes and models and meshes and all cool stuff to do interactive 3D. So what is WebGL? WebGL is a low-level API for the browser. It's very close to OpenGL in that it's based on OpenGL ES, OpenGL for embedded systems, which is the OpenGL that is used on your Nintendo Wii, Nintendo DS, PlayStation, Xbox, Android phones, iOS phones. If you're doing GL type stuff natively, you're probably using OpenGL ES. It uses the canvas tag and it's hardware accelerated. It is supported in pretty much every single browser on the desktop except for IE, and there is some support in Android for the Chrome beta browser there. So there's a good reason why this talk is titled WebGL in Three.js, but most of the talk is going to stay in Three.js land. Just a quick poll, how many people in here have used OpenGL? Okay, for the people on the video, that was about, I guess, like 60% of the people. And how many people enjoyed using OpenGL? Okay, I think that was one in the back. So that's kind of the experience that you have when you're using WebGL. Is it's very low level and it allows you to do a lot of stuff, but there's lots of code to manage, lots of structures to manage. And we'll see a bit more of that later. So Three.js is a 3D scenegraph library that abstracts away all of the nastiness of WebGL. It gives you a very simple and sort of cross-platform way to target Canvas 2D or WebGL. And there also is a renderer for SVG that's not exactly used as much. And then in addition to that, you can also move around objects, HTML objects using CSS3, using the same sort of function calls and APIs. It can import models from all of the major 3D modeling applications. We'll talk a little bit about that later. So you aren't stuck with making snowmen and box houses and things like that. So we're going to start with creating a basic app, a basic scene. And the components of your basic scene are the scene itself, which is kind of the controller. You can come in. Je ne sais pas. The scene is kind of the controller for everything. It's where all of your lighting will attach. It's where all of your models are attached to, all of your cameras, things like that. Camera, obviously, is how you see the world. The renderer actually does the job of drawing the world, and then lighting. And then lighting is something that's optional. You can just use a base light, or you can do funky stuff with like shadows and all that types of things. So quick little bit of code. That line down there at the bottom is how you instantiate a camera using the field of vision, or the angle from the center line of the camera that determines how much you can view in the world. Aspect ratio is the, I can never remember if it's height divided by the width or width divided by the height, but it's one of those. The near and far planes are the thing that's the most close to you and the furthest from you that you can still see. And the target, which is in brackets there because it's optional, is what you're actually looking at. And then you can also separately set an up vector to change how the camera is oriented in the world. Oops, went backwards. Okay. And I'm going to apologize for the people who hate CoffeeScript, but I think it's awesome. And it's my talk, so I'm using CoffeeScript. So, but CoffeeScript does compile down to JavaScript and all that stuff. It's just, I come from a Java groovy world, so it fits my mindset with object-oriented stuff. All right, so for this snippet of code, you have a renderer, WebGL renderer, and we're saying that we want nothing to be in the world, everything to be colored black. We next set the width and the height of our scene. The next bit is a little bit of camera code that we saw before, and that second line, we're orienting the camera 100 units back on the z-axis. We continue by making a scene. Ooh, pictures being taken. We continue with the scene. The next two lines are a bit of jQuery awesomeness to take the canvas element that the renderer created and slap that on the page. And the last couple lines here are adding the scene to the camera and actually rendering the scene. This has been slipped out of, pulled out of the function calls just so I can fit it on one page, but you would use like request animation frame or something like that to make sure that it's continuously rendering. You can also create meshes. There are some built-in geometries, which are just the vertices and faces and things that describe a mesh. For all of these types and even more, you can create your own just basic geometry and add vertices or import it from another application. Excuse me. And we see on this first line here, we have a mesh. We have a mesh that is comprised of a cube geometry and a basic material that's just shaded red. That's one of the weirdnesses about Three.js is all of the colors are specified using hexadecimal. Well, not really weird, but interesting, because I'm used to JavaScript sometimes where you can say red or green or whatever. So it's slightly different. And for materials, we have the basic one that we saw there, which is just a matte color. We have materials for Phong shading, which interpolates on the vertices and the pixels, I believe. Lambert or diffuse shading. You have line shaders. line materials, and then you have a shader to allow you to do more interactive and interesting stuff, and we'll look at that a little bit later. So let me go to my code and Python. Okay, that's running. All right, and I have like a little some of the demos here. This is a basic scene, just using a basic color for all of the vertices, for the square and the triangle. And we have another one here where we have it going a little bit more interesting with vertex colors and rotation. And for each mesh that you have in Three.js, they have a couple of properties like rotation and position and scaling that allow you to independently scale or rotate or translate on the X, Y, and Z axis. You would just do, say, your mesh is m.position.x, and you can change that. And go back to the code. And as I was saying before, you can load models. You can load them from Blender. You can load Collada models, 3D Studio Max, Maya, pretty much anything that can be exported can be read by Three.js or can be converted to a format that Three.js can export out, because most of these packages export 20, 30 different formats. And here's a bit of code for loading a model. And you load a model using JSON loader, and it comes with one function, just the load, which takes the URL, and a function for the callback. And when that callback is executed, it passes you the geometry and the materials that have been loaded from that file. So we can see with this one, we are creating a mesh, and we're rotating it a bit on the x-axis and moving it on the y-axis and scaling it. And then lastly, adding it to the scene. Loading a scene is very similar in that it uses scene loader, a function, an object that has just a single load function, and takes a callback. But you can also do you can specify a function that gives you progress so that you can load your scene incrementally, as opposed to waiting until everything is loading and then just everything materializes all at once. Excuse me, sorry. So this functions very similarly to the JSON loader, where once the scene has come back, we just set it and add a camera and all that stuff. There's also a thing called Three.js Editor, which allows you to do very lightweight scenes and playing around with objects. And I think I have Wi-Fi. I might not. Okay, cool. All right. So this is actually an instance of Three.js running in a canvas right here that can also export Three.js scenes, which is kind of cool. So you can set the different renders that you want to render, like you couldn't use WebGL if you're on IE. And the menus up here have objects that you can create, and you can change the different properties on them, add textures and stuff like that. You can also add lighting, and I think that light put it like right here. And the coolest part about this is you can export individual geometry or a whole scene at once, and it spits it out in JSON format. So that. Okay, and I'm sorry. I was in Rome last week, and then I went to London, and it was cold, and I caught a room, so I've been kind of flummy. Okay. All right. So let's show some more demos. And dang it. I was good like 20 minutes ago, and then you get lights on you and your nose starts running. So you can also do textures. And you can sort of see the line right here that starts with image utils. Let's see if I can scroll over. Load texture, and you pass a URL to where that texture is located, that image file, and then the only thing that you have to add is map and then that texture object to texture anything. Now, because this is a cube, it kind of knows how to texture it. If you had some really advanced model, you would probably use Blender or 3D Studio Max and have like an artist kind of map how that texture is gonna go on that object first, and then export it to Three.js, and then somebody got 34. Okay. All right. So GLSL is a acronym for graphics shader language. And it's basically a way to target the GPU and the graphics pipeline. And this was kind of what I was talking about with shaders. It uses a language that's very close to C, which is not fun for me because I hate C. You can pass these shader programs around as strings. They can be compiled and generated and compiled and run at runtime. And the combination of a vertex shader and a pixel shader is called a program. So vertex shaders, as the name implies, they run once per vertex on a mesh. They can alter your color, your position, texture coordinates, and things like that. And here is an example of the most basic sort of vertex shader that's converting from world space to projection space to show on your canvas. And we also have pixel shaders, which run once on every pixel in a mesh. They don't know what's going on with any of the other pixels. There is a way that you can transmit messages between shaders using a thing called uniforms. And that's useful for things like bump mapping or shadowing, something where you need to have a graduated effect as you move to or from a certain pixel or vertex. And here is an example of a fragment shader or pixel shader. And back to the class participation part of the talk. Can anyone tell me what this does? Anyone, just yell it out. What was that? Yes. He said that it colors it in green. See, I can translate a little bit. So this is kind of the most basic one, and actually for anything that you do in Three.js, this is going on behind the scenes. When you do a basic color, it turns it into a shader, and so that's all a part of how it cuts down the amount of code that you have to write when you're doing Three.js versus WebGL. Here is kind of a more extreme example doing Toon shading or making the object look more like a cartoon, like an old school cartoon. And we're changing colors, and then we're making functions and all that stuff. And we have like uniforms to pass things back and forth. It's kind of crazy. But it's only in my slide deck, so I can show you how it looks, because how it looks is cool. And this one. So that's all done using shaders that the people on that site came up with. So you're not limited to just, black and white sort of things. And okay. There is another thing called Shader Toy, which allows you to play around with shaders or create your own. It has about 50 or 60 different presets that you can kind of tweak and, whoa, almost just have. I almost spilled lots of liquid on my pants for the second time in this trip. So yeah, so you can play around with shaders, and I advise you to check it out because it's really awesome and like that. I'm not going to run it now because I'm not, but it's awesome. Check it out. And okay, I'm good. All right, what do I want to show you guys now? Okay, all right. Moving back to sort of gaming stuff, Three.js has the capabilities to do collision detection. For every mesh that you create, there is a function to create a bounding box or bounding sphere. And there is a partner library for inside of Three.js that does all types of math stuff like collisions between rays and planes and all that types of cool stuff. So you can definitely wire up your own if you're doing a smallish game, or you can use something like this, Physijs, which is a library for Three.js that integrates very deeply with the core package, and you can wire up a scene for animation, for physics, with like 5 to 6 lines of code. And for the C++ geeks, it's built on top of Ammo.js, which is a port of Bullet SDK from C and C++. And all right, there we go. And this is an example Physijs scene. One of the key differences that we see is instead of 3.scene, we're doing Physijs scene, and we're setting a gravity on it. And instead of 3.mesh, we're doing Physi.mesh. So, yes. Excuse me. And this one, this is an example of loading a scene that I created in Three.js editor. And this next one is a very slow physics scene because I'm working on a Chromebook, a 2-year-old Chromebook, because I'm either crazy or awesome for trying to use equipment that's for purposes that it isn't meant for. You be the judge. So it's going to start a little bit slowly. So we have it's chugging along there, and it's going to impact that first one and slide along, and then drop to the second one and kind of rolls back a little bit. All right, and then close that. Sorry. Okay, have 27 minutes. All right. So I'm going to tell you a story right now that's, I'm hoping there aren't people in here who were born in the 90s, because then I'll feel really old. But this is my first computer. It is the ColecoVision Atom 2. It came out in 1981. 82, sorry, it came out in 82. I was born in 81. It came out in 82. And it has, you see there's no monitor there. The way that it worked is you hooked up your TV to your computer. And you can notice in there you have 2 paddle game controllers for the game that was very famous at the time, Pong, and a 5 1/4 drive, and 2 high-speed tape decks that for any application you tried to load, it would spin at a very high-pitched screeching sound for 5 minutes in one direction, stop, spin in the other direction, stop, and do that for like 10 minutes before it loaded the game. And this particular computer also had a weird bug where if you went into the word processor, which was just kind of a blue screen, sort of like Doogie Howser. I'm not sure if you guys had that show here with Neil Patrick Harris when he was like a kid doctor. Probably not. Okay. So anyway, the word processor is just a blue screen where you just type in it. But this computer had a bug where you couldn't, once you went into the word processor, you couldn't use anything else until you rebooted the computer. So we're talking real advanced tech. And my very first game on that system was Buck Rogers in the 25th Century. Used to be a TV show in the 70s in the United States. And the basic goal of the game is you're flying through gates and you're trying to kill these aliens and stuff. You know, very sort of 1950s sort of aliens are going to invade us and robots and we'll all be on Mars by 2010, that sort of thing. So I wanted to kind of create a sort of game that was paying homage to that. Don't have it totally wired up with physics and collision detection yet, but it's getting there. All right, and Python simple server. Oh, wait, that one's like not the same one. Like force it. Okay, there we go. All right, so we have our little ship that we can move back and forth, up and down, and we have our little gates that we can spin through, and we have our enemies, our little flying saucers that are coming in. And you can shoot, but I didn't do any of the collision detection yet, but I'm just flying back and forth to show you I'm not like rendering 2D stuff, and it actually does work. All these models I created in an afternoon in Blender, just very quickly. So you can make really cool stuff fairly easily. And let me close that. And this next demo I'm going to show you is a risky demo because I coded it like last night. After I got back from a nice dinner with one of my friends, Charlie Nutter, who I only see at conferences, but we always have a fun time. He's a really smart guy. So went to dinner, had a couple beers, and I'm like, okay, I want to add more to my presentation because I don't want this to be the same presentation that I gave at DevX London or the same one that I gave at CodeMotion. So I decided to add a sort of racing game-ish car thing that I'd been working on for a little while, but it wasn't all coming together. Just a little bit about it. The server for it is written in Google Go, and it uses WebSockets to do the communication for chat and for where things are oriented. But I literally was just coding this like an hour ago, so some of the stuff is not all there. So I really shouldn't be showing it to you, but I will. All right, so let's go repos. Games are go run go. Do I have something running on this already? Go. Dang it. Okay. Go run. I don't have anything running. Okay, let's hope that this doesn't crash in my face, but it might. Okay, that's not the same one. Localhost 8080. Okay, and let's start another one. And let's start a third. And as we can see, using WebSocket so I can chat in between the 3 instances and it updates everything. So that's mainly there just to show you I'm not faking this. And that's the one. Start up and you can see very in the far back there that's a car. And let me start up for this one. I found some models of cars that I loaded in. It's like 12 of them. So it's just kind of picking a random car for each instance. Excuse me. All right, so we have a couple of different cars, and we can move around or stop or whatever. Okay, and I'm in the wrong thing. And let's move that one backwards. And what we can do is when we send the state to the server, I think that might have crashed, but we'll see. Server. Yes, it crashed. Gosh. Okay. But anyways, since there's like 19 minutes, I'm not gonna try and reboot or get it working. That's part of the risk of doing a demo that you were coding 20 minutes ago. Is sometimes it works, sometimes it works awesome. So pretty much all I forgot about this. WebGL Inspector, that's right. So the WebGL Inspector is similar to the Chrome Inspector or like Firebug, but just for WebGL scenes. So it allows you to step through and see what's going on a command-by-command basis. You can view shader programs, assets, all that types of stuff. So let's actually repurpose one of our scenes that was acting kind of funny. Yeah, the server did crash. Okay, let's just start it back up real quick. Okay, now it looks like it's working. Okay. You win some, you lose some. All right, and if I start up the race game, okay, so when you have the extension installed, which I installed previously, it brings up a little UI for capturing an individual frame or showing the UI. So we have this car in here. So the only thing that's in our scene is a camera, a light, a car, and a plane that the car is resting on. So if we capture an individual frame captured, we can see right here, this is everything that it takes to draw that individual frame. And I'm still scrolling, and I'm still scrolling. Okay, 393 lines of code to deal with all the stuff to draw that frame. And what you can do with the WebGL Inspector is if you click an individual line, it shows you what has been drawn up to that point. So up to line 33, we just draw the ground and different things like that. You can also see the different shader programs, which for everything that we had as a color, a basic color or something like that, it generated a shader. And this is one of the Vertex Shaders and one of the fragment shaders. I think there's a longer one here. Nope, they're all about the same size. You can view textures. This car is using a lot of them, so everything is pretty much a texture in here. But the WebGL Inspector is a nice way if you want to go to the dark side and use raw WebGL or know a bit more about Three.js, what it's doing behind the scenes. It's a good place to start. And with that, I'm done and I'm open for questions. So we have about 15 minutes. So the gentleman is going to have the microphone. So raise your hands or whatever. Excuse me.
En français?
Okay, I'll try.
On parlait de problèmes de sécurité il y a 2 ans pour WebGL.
Okay.
Qu'est-ce qu'il en est aujourd'hui?
Okay. We have people have been talking about a problem with security with WebGL. Is there any news on that front? Okay. As I would say that from a security standpoint, it depends on what do you mean by security. If you mean, because one of the questions that I got that I received in a previous talk was, how do I secure shaders that I might be creating to do some really cool effect for an online game or something like that? And there's not really a good answer for that. There are kind of ossification type things where you munge it up and then decode it just before you use it and uncode it. But I don't really have a good answer for that. If you're talking about security, as in the stuff that Microsoft is saying about WebGL not being secure, I don't really buy that. So I don't know. I don't even have an answer for that. So, quoi? Could you get the microphone? Because I can't hear that.
Et pourquoi vous n'êtes pas d'accord avec Microsoft?
And why am I not in accord, or why do I not agree with Microsoft? This is on tape, so yeah, I'm just not going to answer that question. Anyone else? Yes, I take the fifth.
J'ai cru comprendre qu'on pouvait manipuler des objets du DOM via WebGL. Est-ce que vous pouvez nous en dire un peu plus là-dessus, comment ça marche?
The question was, can you manipulate DOM objects using WebGL, and how would you do that? It's not, I didn't really cover in the talk, but you would use a separate renderer, the CSS3 renderer, and that actually can move around DOM elements, and it would be kind of the same way that I demonstrated moving 3D objects. The only difference is sometimes you have to create sort of a representation of what that object is for that renderer so it knows to move it. There's a little bit of a channel that you have to cover for that. Cool.
I wanted to know, how do you deal with performance issues?
Okay. How do you do? Oh, he said it in English, and it was sorry. Performance is well, a lot of the wonderfulness about WebGL is that the modern browsers, Chrome, Safari, Firefox, like optimize insanely on everything, so you can kind of ride on their shoulders. And when I'm creating stuff, I kind of scale it to the machine that I'm working on or the target machine. So like for this demo, because I'm running it on a 2-year-old Chromebook, I'm not going to have 50 million things on the screen, and just basic tricks that you would use from OpenGL land, where like back in the day, every single game had fog in it. And that wasn't because they liked the ambiance of fog. It was because if you make fog, you can allow objects that are far to not be seen and have them appear slowly and have it be more immersive. So it's just the basic things like that that you would deal with performance. Cool. Anyone else?
certaines entreprises utilisent le VRML. Est-ce que c'est possible de le charger comme modèle un jour dans Three.js?
Okay. Certain companies use VRML. Would it be possible to use that with Three.js? I mean, you could write a converter because a lot of VRML scenes are very limited when it comes to the types of geometries that they're using. So if you can, boil it down to using base types like triangles and squares and stuff like that, you could probably find some software application that can import VRML. Like I think 3D Studio Max and Blender used to at one point. They might still. So that would probably be the path, is to import those models into another format, because VRML doesn't really have that much movement in the general kind of geekery space as much. So there's one back there. Oh, he's bringing the mic.
Est-ce que c'est possible de redessiner juste une partie de la scène? Is it possible to redraw only one part of the scene? And how would you do?
No, not that I've seen. It's the whole scene. Yeah, I understand what you're talking about from, back in the day with like OpenGL, where you would have like clearing a certain box and then only redrawing that box. I have not seen that as much with Three.js, but it might be there, but I haven't seen it. I've only seen redrawing the whole scene at once. There's one in front.
Yes,
here.
Supposons qu'on fasse un FPS avec un FPS classique, il n'y a aucun moyen de se prémunir qu'un client modifie le code JavaScript pour enlever
Can
des
you
parties.
repeat that slower? Because for a little time out, this reminds me of when I was at Léotois, Université Charles de Gaulle, and I had this morning class, Monday mornings, one time a week, for 3 hours, Connaissance du monde contemporain. And the lady would lecture your speed for like an hour and a half, go out into the hallway, chain smoke 2 cigarettes, and then go back in for an hour and a half. So it just took me back for a second. I was like, whoa, I don't understand any of that. But go ahead.
Bon, supposons qu'on fasse un jeu donc, avec WebGL, où il y a des informations qui sont un peu cachées. Il n'y a aucun moyen d'empêcher le client de modifier le code de JavaScript pour enlever les choses qui cachent, pour afficher plus facilement ce qu'il veut voir.
Okay, I'm going to paraphrase this a little bit, but the core of the question is about if you have a game and certain data or information is hidden, and particular concerns about the user changing data because JavaScript itself is pretty much fundamentally open. Did that get it about right? Cool. There are different things that you can do, like with the Go server sort of demo thing that kind of broke and didn't work. What was going on behind the scenes was I was sending that data to the server, so you could do something like that where you have the server verify everything, where the client can just change whatever they want, but everything has to be sent up to the server and verified. And I'm going to say a dirty word like SimCity. So that's kind of one way to do it, and it kind of depends on the thing that you're doing. So for chess or checkers or something like that, I wouldn't worry about someone mutating state like that. But for a bigger game, I probably would have some sort of check on server side to verify, or maybe you can like hash something. You have some portion of the information that you can hash where you can check instantly or fairly quickly whether that information has been mutated in the wrong way because it's not signed correctly or something. Anyone else?
Yeah, I want to know if there are other alternatives to Three.js and why Three.js may be, for the moment, the best solution, and in the long term, if it's interesting to invest in this library.
I would say that there are a couple. I've seen some that were some that were kind of transitionary between Flash 3D and WebGL. There is one by the the people who make EXT.js and stuff, called Physijs. What is one of the other ones? Can't remember. There are like 3 or 4. The reason why I personally picked Three.js when I started looking at stuff was just because this is what the demos were for for Google when they had this demo at Google I/O, where it's like this insane Rome. It's called Rome, ro.me. I think it's still online, where it has like horses running and bulls running and all these insane shaders going on and things morphing from one to another. So, I mean, I think it's just a personal choice at the end of the day. A lot of the available packages out there have a commonality in that there's not much literature on them. So a lot of it is about what feels comfortable to you and what you want to invest in. Anyone else? All right. Well, I thank you for suffering. I didn't even see the hand. Sorry, my bad.
Yeah. Is it possible to draw 2D graphics over the 3D scene, for example, to draw an H2D?
Yeah. You can either do it a couple of different ways. You can have like an image or something and position it using. It's okay. You can position it using CSS. You can render inside of Three.js to a texture. So you can create a really big scene and render it to a texture and render the image. Or you can just not use your z-axis or however you oriented your system and just draw 2D stuff. And it benefits from being hardware accelerated. That's becoming less of an issue now that a lot of Canvas stuff, Canvas 2D is also hardware accelerated. But in the past, it used to be just the WebGL stuff was hardware accelerated. So you can use any of those different approaches. Okay. I thank you for suffering through my horrible French translations.